all should get at least 1. See, this is lower limit and upper limit. The person can get, all should get at least 1. And maximum is, or I'll say lower limit is ABC greater than or equal to 1 and ABC less than or equal to 7. Then how you proceed? First take care of the lower limit. Then just solve it like the previous one. Once you see lower limit question, you can directly change it into low limit question, right? Once you take care of the lower limit, it changes to 7, right? Right hand side will change to 7. Now it becomes an upper limit question of 1 is already taken care of, so it becomes 6 now. You need to consider that point also, that's it. And there is a lower limit and an upper limit. When I am already giving 1, 1, 1. Then again you can't take an upper limit of 7. Now you need to consider an upper limit of 6 also. Anyway, we are going to solve those kind of questions. So that's the logic. So this is what we can expect, right? Lower limit, upper limit and a mixture of both. What will be the answer for this? A person must buy or 20 identical apples. How many ways he can give it to? A, B, C, D. A similar question. This is similar to, okay, this is question number. Okay, it's not there. 20 identical apples to 4 persons, A, B, C, D. A should get at least 1, B should get at least 2, C should get at least 3, D should get at least 4. This is similar to that question. See, almost all of you can get the answer without using a pen. A should get at least 1, B at least 2, C at least 3, D at least 4. So, what's the answer? 13C3. It's as easy as that. It's not an easy question, by no means. For conventional standard, this is not an easy one, right? But here it's only a matter of just follow the condition. It says it now. 1, 2, 3, 4, take out 1 and give it to A. B, 2 to B, 3 to C and 4 to D, right? 1 to A, 2 to B, 3 to C and 4 to D. That means 10 are taken out. 10 are taken out. It's only a matter of remaining how many zeros? 10 zeros. And how many ones? 10 zeros and 3 ones. So the answer is 13C3. 5 second answer. But why it is, first of all, it's a basic question. Last year there were 2 CAT questions based on this. And in 2004 there were again one more question based on the same question. A person moving from one point to another point, moving only in positive directions. So 2008 there were 2 questions. We'll see them also. Those 2 questions also we'll see. Not today, in the next session. Now, if I write an algebraic expression, how many roots are possible? Now, this is one root, right? For a person to move from A to B, overall you have to cover 3 horizontal distances and 2 vertical distances. 3 horizontal distances and 2 vertical distances. That is H, H, H and V and V. This itself is a root. Expressing like this itself is a root. What is the graph? This is the algebraic expression. If you want, you can take it that way. Graphical representation will be H, 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 V and V. This is one root, right? This is one root by following the condition. Now if I just change it to H, V, H, V, H, then the root will be H, V, H, V, H. That's a different root. This is exactly what we did initially for zeros and ones also, right? This is H, V, H, V, H. Now, why we can use zeros and ones here? Because zeros and ones are nothing but 2 symbols. So we can write 0 here and 1 here. 0 here, 1 here and 0 here. Alright? So the question can be compared to how many zeros? This is completely unconventional, but this is how, if you start solving it, you can solve a lot more questions than the other way around. So it's based on 3 zeros and how many ones? 2 ones. 3 zeros and 2 ones. Answer is 5C2. Now, just like this. Easier than the 2008 questions. There's something like this. A person is going from A to B. How many ways he will go through? How many ways he can go from A to B via C? This is CAT 2004. It's a now, right? How many ways he can go from A to C, A to B via C? So how do you solve? A to C, how many ways? So this is product rule, right? How many ways he can go from A to C? How many zeros? Just count the number of columns. 1, 2, 3. So there are 3 zeros and 2 ones. That's 5C2. C2B is again 1, 2, 3 and 1 and 2. So 5C2 into 5C2. Answer is 5C2 into 5C2. Clear, right? What is the probability that he will pass through C? That's the next question. What is the probability that he will pass through C? These are the favorable cases, right? Divided by 1, 2, 3, 4, 5, 6. So there are 6 zeros and how many ones? 1, 2, 3, 4. 6 zeros and 4 ones. So it's 10C. Total number of roots are 10C4.
Out. See, this is out, right? Our circle is not required. That means pi is out of calculation. This is not the best thing which you learn in my class. I'm just showing you these are very basic things which you will practice. Very basic things, the most basic thing. Now, answer is just 10 seconds away, right? Maybe not even that much. 10 seconds away if you are dividing. Otherwise, if you can imagine that, answer is direct. 1, 2. Over, right? 1, 2, 3, 4, 5, 6, 7, 8. All equal areas. I'm using the word. They are not necessarily triangles. You need equal areas of any shape. Is it math? No. Or it's just, what is the answer now? 1 out of 8 of 256. So I'm sure all of you can directly relate to this. This will happen automatically once you spend a few more hours in every topic. In geometry, very well in numbers. Where you need to put in some effort is only in numbers. Again, I'm telling you. I need some effort from your side only in numbers, nowhere else. If you talk only from the math point of view. Now, DI adding at any time, DI sessions can only be better if you are just relating it to the logic which we use for solving math questions. DI questions will be something like this. What is this? In terms of 3-set Venn diagram, we'll solve it like this. This is the 3-set Venn diagram for us. Why you need it? Why you need this? Okay, I'm not going into details. Why you need this? Can you draw a 5-set Venn diagram? Can you make a 5-set Venn diagram in a single diagram? Yes or no? 5 sets, 6 sets in a single diagram. You'll do that in CAD. 6-set Venn diagram? 6-set Venn diagram, then I'll learn it from you. For sure. You can make it using a lot of diagrams, but that is not feasible in CAD. How will you solve a 6-set Venn? Then how will you solve a 6-set Venn diagram question? Will you solve it like it's been given in all those practice tests where if you solve it once, you'll never solve those? I'll give you the confidence to solve any Venn diagram question with any number of sets, whatever be the level. I'll give you that confidence for you, everyone to solve, which otherwise are impossible to attempt, I'll say, in CAD. If you get, that is one type of mathematical reasoning questions in DI, not the easiest one. Now, if you're talking about conventional DI where numbers and calculation is involved, how we'll solve calculation intensive DI questions is, I'm not in a position to show you that, because I need to distribute sheets and we need to solve caselets. We'll solve it without doing any calculation. It's just about that. I'll teach you every possible calculation technique from a CAD point of view, not Vedic maths. But I'll teach you to such an extent that you'll never do any calculation. Is it possible? Right now, anyway, you won't believe, I know that, but it is possible. To solve every calculation-based question, you don't need to do any calculation. There are 4 direct approaches. One by using the unit digit, one by using the first digit, one by using the number of digits, and one by using the sum of the digits. You can solve calculation-based questions, or you can eliminate calculation-based questions. And that you can practice it even faster than the math strategies.